Virtual Hacks 2020. My project is detecting pneumonia from chest x-rays, and the reason it's pneumonia, not COVID-19, is because the data set that's more widely available is pneumonia, and the chest x-rays for pneumonia and COVID look very similar. So if a model can work on pneumonia, then it can surely work on COVID once that data becomes available. So after a brief introduction, down here you can see the imported libraries that were used to make this project. And from the data set that was obtained from Kaggle, we'll first take a look at the distribution of our data. So if we scroll down here, as you can see, the data is highly skewed. This is the training data. As you can see, there's a lot more cases with pneumonia than there are normal. And following for testing data, which is a bit more average, and validation data, which is only 9. And the validation data is clearly very low, and the training data is highly skewed. So that would be causing errors. Now if we scroll down here, you can see some normal chest x-rays, and here are some ones that are with pneumonia. Now for example, number 3 over here is very hard to distinguish from one that would be normal. So that's what our model would distinguish between. Now we come to data pre-processing. So first we'll initialize the data frame, load in the data images, standardize them, split them into features and labels, augment the images, and create training batches. So if you scroll down here, as you can see, the data is being loaded in. This display is simply just for Jupyter notebooks. Now over here the data frames are initialized, and over here the data is standardized, and over here it's split, and these are the data frames that were just initialized, and the data is loaded in and it's split into its features and labels. Now here's when the images get augmented. Augmented meaning that the images are slightly distorted, so they look a little bit different, and there's more training data for the neural network. Down here we create batches for our training neural network, and this is the version 1 model that we presume is a convolution neural network, and it uses multiple layers, and in the end a dense layer and a 1 by 1 at the end, which shows that is either normal or is infected. So over here we define the model, and here's a summary of it, and then we begin fitting. I won't run this again because it's computationally very expensive and it will take a long time. So this is the training data, and as you can see, we ended with an training accuracy of 92.9%, and that resulted in a test data accuracy of 90.38, which is not bad, but we could certainly improve upon this because, as we saw in the start, our data was highly skewed when training. And if we plot a graph down here to check our validation accuracy, as you can see, our accuracy rose normally, but our validation accuracy took a big dip over here, and for our validation loss, it took a big rise. Concurrently, the regular loss dropped, and the validation loss was an overall drop as well, which is good. And here's the confusion matrix that shows that our model performed 90% on the testing data, which is not bad. And here's some more statistics, followed by some correct predictions over here, and some incorrect predictions over here. As you can see, the incorrect ones are quite tough to detect. So we found out some shortcomings of our model, increase the size of the validation data, which is one way to tackle a shortcoming, and undersampling will account for the skewed data. Now we build version 2, which is again loading in the data, augmenting it, data framing, all of that stuff. And down here we define the model again, which is exactly the same as version 1, but the difference this time is that we are undersampling our training data, so we have only 1342 and 1342, an equal amount of training data, and our validation data has increased to 116. Now if we scroll down here, same training process again, ends with 92.25, which is slightly better, and as you can see, our testing data, increased by 2%, so it's approximately 92%. And here's our validation accuracy. As you can see, the dip that was previously there has shortened a lot, and here's the validation loss. This spike over here would eventually drop if we had more epochs, but because it's computationally very expensive, I could not do it on my computer. Down here is the confusion matrix again. This is for 92% accuracy as opposed to the 90% we had at the start. And these are some incorrect predictions. This is a typo up here, my bad. And as you can see, these are the incorrect ones, and down here are the correct predictions. Also, this model does have a bunch of shortcomings. So small training data because we undersampled, and the X-ray data is not diverse in the sense that it's very hard to detect between pneumonia and normal cases, as mentioned down here. And that's all for my project for Virtual Hacks 2020.